All right, guys, welcome to lesson 8. In this lesson, it's going to be a short one. We're talking about linear and absolute value inequalities. An inequality says that one expression is greater than or equal to, less than or equal to another. You solve inequalities just like normal with one exception. If you multiply or divide by a negative, you must flip the inequality. Okay, so like normal, we're going to solve this thing. So we got negative 3x. We're going to subtract the 5 to the other side, and that's going to give us negative 12. When I divide by the negative 3, that's going to force me to flip that inequality. So you got x is less than positive 4. Okay? So if I draw a simple graph, simple number line, all right, I got 4, and the less than tells me the direction that I'm going to shade. So I got parentheses and shade to the left. And then my interval notation is negative infinity to 4, parentheses on both. So let me stop here and talk about shading and interval notation. So with inequalities, they could ask you for one of 3 answers, and sometimes it's a combination of them. All right, you can get the inequality, which is the x is less than 4. They could ask for the graph, which we showed, and they could ask for the interval notation, which is what which is the parentheses down here, the thing I have highlighted. All right, so a couple things. If it's less than or greater than, you use parentheses on those numbers. If it's less than or equal to, greater than or equal to, use brackets on those numbers. And we'll look at that in just a second. And then a parentheses always goes on infinity. Whether it's positive or negative, you always use parentheses on infinity, because infinity is a concept. It's a number that is always getting bigger or always getting smaller. You never actually get there. So it's hard to say this is where it is, because it just keeps going. And then another thing is that when it comes to inequalities, in previous lessons when we talked just about equations, I said that you could use, you could put the x's on the variables on the left or the right, and it was really down to preference. With inequalities, you really need to make sure that your x's or your variables are on the left, and it reads from left to right, because otherwise it doesn't show you where to shade. It doesn't show you where to shade, and it doesn't read right. Like a less than is a greater than, and so on and so forth, and it can just really be confusing. So make sure that your variable is always on the left when dealing with inequalities. So let's keep going. On number 2, I got negative 2x. I'm going to subtract the 7, and that's going to give me negative 12. So I'm going to divide by negative 2, and since I'm dividing by a negative, I got to flip my inequality, and that's going to be greater than 6. All right, so I'll draw a simple number line, 6, and I'm going to, because it's just greater than, I'm going to do a parentheses and shade to the right. All right, and then I have my 6 is my lowest value, and I go off, I increase without bound to infinity, and parentheses on both. All right, number 3, we have a less than or equal to this time, so there's a good chance we're going to have a bracket. All right, so getting my x's on the same side is going to be negative 5x. So 4 minus 5x less than or equal to 7. Negative 5x less than or equal to 3. I'm dividing by negative 5, so x is greater than or equal to negative 3/5. All right, so I'm going to draw my number line. All right, I got negative 3/5 in the middle. I got greater than or equal to, so I'm going to do a bracket, and I'm going to shade to the right. And the bracket comes from the fact that that's greater than or equal to instead of just greater than, and it's pointing to the right, so I shade to the right. Now, when I do my interval notation, it looks like this. I got negative 3/5 on the low end going to infinity. The infinity always gets parentheses, and there's a bracket on 3/5, a negative 3/5. All right, so there you go. Number 4. Let's see, I got 3 minus 6x greater than or equal to 8. Negative 6x greater than or equal to 5. X is less than or equal to negative 5/6. I'll do my graph. I got negative 5, 6 in the middle. And this time it's a bracket but I'm shading to the left. Okay, and then my inequality, my interval notation is negative infinity to negative 5 over 6. You always go from least to greatest when you write your interval. Okay. Now, what about unique solutions? Okay, so let's take a look at this. So we got 2x plus 8 greater than 2x plus 3. I'm going to move the 2x, and that's going to leave me with 8 is greater than 3. Well, that's a true statement. So when does this happen? Always. So in this situation, my answer is all real numbers. It works every time, so my answer is all real numbers. If you're writing the interval for that, that would be negative infinity to infinity. All right, what about number 6? I'm going to subtract the x's, and that's going to leave me 7 is less than or equal to negative 2. Well, that's not true. Negative numbers are never higher than positive numbers. Okay, so this is no solution. No solution. And you can spell it out, or you can say 0 with a line through it. All right. Now, what about compound inequalities? Compound inequalities, you have something in the middle and you have something on either end. And they look weird, but they're not that difficult at all. So I need to get the x by itself. So whatever I do to one side, I do to all sides. So I'm going to subtract 5 from everywhere. And that's going to give me negative 7 less than 3x less than 15. And then I'm going to divide by 3 everywhere. And because I'm dividing by a positive number, my signs don't change. So I get negative 7/3 less than x less than 5. And the beautiful thing about compound inequalities is it's telling you exactly where to shade. You're going to shade in between. So you got negative 7/3 on one end, 5 on the other. Parentheses, parentheses, shade in between. All right, and then your interval notation is going to be negative 7/3, negative 7/3, comma, 5, parentheses on both. Looks like an ordered pair. Okay. Number 8, same thing. I'm going to add 8 to both sides, or all sides, and so that's going to be 9 less than or equal to 6, x less than or equal to 12. Divide by 6. So that's going to be 3/2 less than or equal to x less than or equal to 2. So I draw my line. 3/2 on one side, 2 on the other. And because I'm dealing with less than or equal to, I'm shading in between, but I got brackets on both ends. And then you got your 3/2, comma 2 bracket on both ends. Now, there are situations where you have a bracket and a parentheses in the same interval. So just because it's on one side doesn't necessarily mean it's on the other. It really just depends. So if one of these signs was just less than and not less than or equal to, that would change up the interval a little bit. So just be mindful of that. Now, absolute value inequalities. If it's the absolute value less than a number, it's going to be one of those compound inequalities we just looked at. If its absolute value is greater than a number, then it is an or statement, which is what we started with in this lesson. So on 12, we have an absolute value less than a number. So this is going to be negative 3 less than x minus 4 less than 3. Okay, so I got, let's see, add 4 to all sides. So add 4, that's going to be 1 less than x less than 7. And so 1 comma 7, parentheses on both, is my answer. I'm shading in between. On 13, I need to get the absolute value by itself before I know which one I'm applying. I got 3x plus 5. Greater than or equal to, subtract 7, that's going to be negative 20. Dividing by negative 2, so it's going to be 3x plus 5 less than, or close the absolute, less than or equal to 10. And this is why we get the absolute value by itself first, because sometimes when solving these things, the sign changes. But once it's by itself, the changing is over. All right, so now this is absolute value less than some number. All right, so that is another compound inequality. So you got negative 10 less than 3x, or less than or equal to, rather. 3x plus 5 less than or equal to positive 10. Subtract 5, so you got negative 15 less than or equal to 3x, less than or equal to 5. So divide by 3, you got negative 5 less than or equal to x, less than or equal to 5 over 3. And so negative 5, comma, 5/3, bracket on both. All right. On 14 and 15, the absolute value is on the wrong side of the inequality. So the first thing I'm going to do is I'm going to write it the correct order. So the absolute value of 5 minus 2x greater than 7. On 18, I got absolute value of 6 minus 3x greater than 18. All right, so because this is an absolute value greater than a number, this is going to be an or statement. So I got 5 minus 2x is greater than 7. So the first one, because this is not equals, this is inequalities, the first one is exactly the way it looks without the absolute value. Or, and here's where you change it. 5 minus 2x, change the inequality, so it's going to be less than, and then change the sign. So it's less than negative 7. All right, so I got negative 2x greater than 2. X is less than negative 1. I divided by negative 2 there, so I got negative 2x here, less than negative 12. X less than 6. All right, so where do I shade? All right, typically with an or statement like this, you're going to shade in opposite directions, but we're just going to be sure, so we're going to draw a number line. And negative 1 on one side, 6 on the other. That should be greater than. All right, so parentheses, shade to the left, parentheses, shade to the right. And so how do you write that in an interval? Well, you always go from least to greatest, so you got negative infinity to negative 1, parentheses. You got 6, you jump to 6, and you got 6 to infinity. And we connect these with a U, which stands for union. All right, so that's how that's done. All right, let's do this last one, and then we'll be done. So we got 6 minus 3x greater than 18, or I got 6 minus 3x less than negative 18. All right, so we got negative 3x greater than 12. X is less than negative 4. Negative 3x less than negative 24. X is greater than 8. All right, so we got negative 4 on one side, 8 on the other. We got less than and greater than, so parentheses, shade to the left, parentheses, shade to the right. And so that's going to be negative infinity to negative 4, parentheses, union, 8 to infinity, parentheses all the way around. All right? So I hope you got something out of that. That's the end of lesson 8. I'll see you in the next lesson.